Like I said, where possible, clean the inaccuracies and inconsistencies, and then absolutely, if you can, if the systems do support it, validate that the data does comply with the specific standards before data mapping actually begins. So if you don't understand the standards of the target that you're trying to reach, you can't effectively map things, right? If you do map things without actually understanding the standards, what are you actually mapping this against? So there could be some standards in place in different organizations. You could have an organization implementing standards A, B, and C for certain aspects of data. The other organizations doing something different in their own proprietary standard, but to achieve the same objectives. So you need to understand that very carefully. When you start doing data transformation at a more central level, you need to talk apples with apples. Otherwise, you're going to have issues when it comes to the consistency of the data patterns. And then, of course, standardized format. Data coming from different sources that conform to common standards makes it easier to map because the formats are predictable and consistent. Sorry, I think I just repeated what I just said earlier. The next slide, please. So looking at map data element by element, and that's actually quite important to actually really understand that as well. So that what that really means is, as you navigate some target systems format and structure, look at the data element and try to, first of all, associate the data transformation requirement, in other words, the mapping requirement at the particular level first, and map them out consistently. Maybe you want to have some sort of documentation that describes this. You want to add some specification documentation documented, because that way of solving one organization standard implementation kind of mapping process won't necessarily be exactly the same with another organization. So you've got three organizations capturing the same information but doing it in a different way. You need to describe this very carefully and very clearly. Otherwise, you're going to have solution A to problem B, to problem A, solution B to problem B, and so on and so forth. You don't want that. You want one solution that speaks to all the different problems, right? And you can do that through data transformation. And then leverage automation tools. And this is where OpenFN is going to be talking a lot to some of the work that they've been doing, which is really cool. So you have these great applications. They provide a graphical user interface, which simplifies the complexities or reduces the complexities when it comes to complex data transformation requirements. I don't know how many of you have been very involved with FHIR. FHIR can be very technical, very complicated. I love FHIR. I think it's very interesting. But if you don't understand it, mapping, you're going to really struggle. So you need to understand the specification, understand the anatomy of the FHIR resources, work your way from there into data transformation, very importantly. And also the reason why I'm saying that is as you start building out your ecosystem of FHIR to solve particular use cases or problems, you might later on integrate to other ecosystems at a different, it could be a horizontal, it could be vertically, and they've maybe done something in some way which might be more appropriate. And suddenly you have different versions of data mapping requirements that's giving you different data, storing in different locations on a national FHIR server. You're going to have problems when you have a national implementations guide, and I'm just going to start rejecting data. If it doesn't understand, I understand this implementation, I don't know what you're doing, I'm going to reject you, then there's data transformation requirements that need to be updated. And then document the data mapping process. Sorry, I think I might have repeated that a few times. And testing. So what that really means is, so once you've done your data transformation, you've created it, you've written this, your statements as such, you've implemented in some staging environment, make sure, analyze that the data you're getting back, first of all, are you getting data back where you should be getting data back? The data that you are getting back, is it of the correct data type? Is this the type of data that you're expecting? So write your test cases. I mean, you probably, if you can, use the tool, like maybe some EMR that you can use to do this testing. Great. You can actually use things like a Postman for this testing. It's not going to, I prefer to rather use a system that could be staged to support the testing. Otherwise, you could use the Postman, like I say. I just describe these test cases and make sure that there's an analyst for one, a QA engineer or QA tester, I'm not quite sure what you call them nowadays, that actually can ensure that they can assert that the data that's been provided back from the transformation is actually appropriate, right? And testing across the different organizations on which you're going to be implementing or executing these things against. Next slide, please. Yeah, so complex data structures, I think I might have kind of focused on that quite a bit already. So another challenge facing standards and interoperability would be the standardized data formats. I think we've touched base on this already. I don't want to repeat things, so I do apologize. I think I might have jumped around a little bit. I think I might have been through all of this already. One thing in particular, data quality issues. Incomplete data, errors, and inconsistencies are common in data mapping projects. I mean, I've been involved with mapping now unofficially for about, I don't know, 3 months or something like that, like doing research into structure maps and just like, trying to get things done. But if you're not doing this right, if you don't actually understand what your requirements and what the problem you're trying to solve, you could actually make mistakes. You could have inconsistencies of data and so on and so forth. And then eventually, when you have data that's not been transformed appropriately, when you get it to a reporting system, some data warehouse or whatever, now you're going to have data that's either wrong or data that's missing, and it just causes a big challenge when it comes to national indicators. There's another issue. And tool selection, what are you going to use for data transformation? That's another important thing you want to consider. Are you going to use mediators? That's a traditional approach with interoperability layers. I mean, for many, many years, create mediators. You transform and you orchestrate, right? Sounds simple, but I mean, you start doing static mappings in these mediators, which can become problematic later down the line. And then again, like tools like OpenFN, which will, that team will talk a little bit later. And then, of course, FHIR, it's a relatively, I wouldn't say upcoming trend. It's been around for a good couple of years, but I mean, it's becoming a hot topic in the FHIR community, is the use of FHIR structure maps to support data transformation. Something that's another tool that you might want to consider. Those are the only three I do know of, admittedly. I don't know if there are any more, but it's just something to think about. Okay, I think that's it. Thanks.
Awesome, thanks, Richard. So now we're going to share just some examples of what this looks like in practice in the field before we go to breakout sessions. So yeah, Tom, do you want to come to the microphone? I can also give you the laptop.
Hello, can you hear me okay? Okay, yeah, so I'm just going to talk a little bit about a real world use case with the CHT and mapping from non-FHIR to FHIR. So we had a antenatal care workflow in Nepal that required an integration between OpenMRS and the CHT. So basically pregnancies would be registered in remote areas in Nepal, offline with the CHT or even via submitting SMS messages. And then subsequently patients would come to larger facilities which were running OpenMRS. So the data that was collected with the CHT or SMS needed to be available when a patient returned to their local facility, which was running MRS. So, as I said, the CHT is not FHIR native, doesn't have any FHIR capability natively, but OpenMRS does. And so use the FHIR MRS provides to actually do this integration with FHIR instead of a native CHT to OpenMRS integration. So when we were looking at the tooling and how to do the mapping, we had a lot of options. Some of these were discussed in the earlier sessions. One thing was in the CHD itself, there is some mapping capability. So this would basically be integrating FHIR into the CHT as a sort of facade API. Another option is or the mapping resources in FHIR, or a mediator with OpenHIM, or some tools like OpenFunction. For all of these, the questions that we're trying to answer is how are the mapping configurations stored? What happens if the workflow is changed such that the mapping needs to be changed? Who owns that change? How does that happen? And just generally, how are any changes to these mappings deployed? So the tooling that we ended up using was a custom mediator with OpenHIM. So if you're not familiar with mediators, what it is it's basically a middleware or a bit of code that can do a lot of different things, including mapping, but can really do anything that's required to mediate between two applications using FHIR. And so in our case, we used it for the mapping as well. And that had some things that worked well about it, some things that did not work so well. So some of the things that we found that worked well about using a custom mediator was that the mapping is done just by writing regular code. So application developers we use JavaScript. You can use any language with the mediator, but we use JavaScript, and application developers are usually very familiar with JavaScript or any other common language that you might use. And then contrasting that with the FHIR mapping resources, structure maps, which can be a bit more specialized. I think some of the earlier presenters have said that they were a little bit difficult to work with, which was my experience also. And then mapping in JavaScript is very powerful, and it's a functional mapping instead of a declarative mapping. So that makes it easy to deal with edge cases around things like formatting, even something as simple as someone's name has a lot of edge cases that you have to deal with. Trying to fit that into a declarative structure, I think usually can be done, but can be a little bit difficult to work with. And so just being able to write a function that does whatever you need it to do can be in some ways more straightforward. And the other thing with mediators is that they also can do orchestration. So given that we also separately from mapping have a need to do some orchestration, involving calling different systems, exchanging IDs and replacing references, that means that we can include the mapping in that same infrastructure elements, and we don't need to deploy anything else to store any configuration or data dictionary. And in the case of the CHT and OpenMRS, the problem is that there is not anything, their configurations don't necessarily belong either in the CHT or the OpenMRS. So to use something like a structure map, we'd have to define something else that stores those structure maps and that processes them. So some of the things that don't work so well and didn't work so well with custom mediators is that the mapping becomes code instead of configuration. So the good thing about custom mediators is you can do anything, but also the bad thing about custom mediators is you can do anything. And ideally, this type of mapping should be modeled as a declarative thing, something that's in configuration, rather than just an arbitrary bit of code that can do anything. With just using code, it can end up being a little bit unstructured, a little bit difficult to maintain because there's no structure to it. It's just a bit of code that can do anything. And it doesn't totally answer the question of extensibility, and just in general, it can be a little bit fuzzy about what exactly a mediator is responsible for. And when something changes and needs to be extended, what does that mean for the mediator? And who does that change, and how is it deployed? So it is a mediator between CHT and OpenMRS, and then any workflow fits into that mediator. Is it for a specific workflow? Is it even something else? Those types of questions are not totally answered, at least in this deployment. And then the other thing is that since the mapping is code, not configuration, it requires all of the things that around code that you always need. So you need a way to deploy it, you need logging and observability, you need documentation around it, and you need some process on how to change it and deploy it. Whereas if it was a configuration element like a structure map or data dictionary or something like that, it's more likely that it would be just uploading the configuration to some service that's already running and can understand that configuration. So I think Alexa is now going to go over the open function.
Well, maybe any questions for Tom? Maybe to read through. Yeah, go ahead.
Yeah, I just wanted to maybe back to the questions that we are asking. So in this case, we are mapping just for transferring that information from system 1 to system 2, not in terms of storage, not any of that, right?
Yes. So, like in this specific case, and I guess in most cases, the assumption is that the systems on both sides are managing their own storage somehow. So in this specific case, like CHT, the open element, it's expected to just SMS fit into some format, and it does its best to try and parse that out. Let's see.
Okay.
But that does have implications for things like FHIR mapping, especially because it makes data validation very difficult, especially without any sort of like conversation aspect. Like the data quality from SMS is usually like pretty poor, and the thing is that there's not really anything that we can do to validate forms. We kind of just get the data that's submitted, and that makes things more difficult in terms of mapping because we have to try and deal with those data quality issues in the mapping, rather than if it was like an online form or something like that. You have data validation in the form, and you don't have to worry. You can sort of assume that the data is in the right format in the mapping.
Thank you, thank you. Maybe lastly, how are you handling errors and validation? Are you handling them from the middleware, the mediator?
Error handling has to be handled either on the CHT side or the OpenMRS side. And however those applications like handle errors usually is how they handle errors with the interoperability.
Thank you.
Okay.
Otherwise, we will have full sessions.
Just a small thing.
While this transformation, would you prefer real-time or post-processing? Which is more acceptable?
It doesn't stand, Bob. The battery's flat.
Yeah. Should I try the other one?
Can we put this thing on charge? How long or not?
Oh, okay, yeah, now it's working. Cool. So I'm going to be talking about a case study on this non-FHIR to FHIR integration that we did in Indonesia using OpenFunction as a mediator. So the problem that we were trying to solve was that the government of Indonesia had mandated every facility in Indonesia to send their patient records to a FHIR standard, a FHIR-based Satu Sahat, a shared health record system. And our partner, Asri Clinic, was using ComCare as their EMR, where they were capturing patient records and their visit information. and we had no way of interfacing those two or connecting or syncing data between those two systems, a non-FHIR application based on ComCare and Satu-Sahat FHIR-based shared health record system. So that was the problem that we went into solving. And the solution that we proposed was automated data exchange using open function. And we had created workflows to automate the data mapping, the transformation, error handling, and some logic-based routing because they had a number of use cases, a number of visit cases that had to be mapped to individual FHIR resources and sent to Satu-Sahat. So yeah, we had to implement like this business process where if we catch an error or an invalid data, we would log it somewhere and send it to admins for further refining. And valid data would get routed to their individual workflows. So we might have like a doctor visit, a pregnancy visit, an immunization visit, and each of these would get routed into their own pipelines or workflows where they get processed, mapped, and then sent to Satu-Sahat. So open function, just want to give a brief introduction on what it is. It's an open source data integration platform, but it doesn't only do data integration, it also does process automation or business automation. So it has like a very low code interface where you can configure your workflows. So you can see it here. This is our canvas for configuring the different workflow components or steps in your workflow or in your pipeline. And we have these adapters that connect to different systems, mostly commonly used health information systems like ComCare, OpenMRS. And we also had to build one for Satu-Sahat so that we can easily connect to Satu-Sahat. So adapters basically provide us with shortcuts and tools to easily connect to that system, to fetch data from that system, or to push data to that system. So we had to build an adapter for Satu-Sahat because that was our first time interfacing with Satu-Sahat. And we already had an adapter with ComCare because we've had previous project with ComCare. And so what we designed was a workflow or multiple workflows that extract data from ComCare and do some processing, mapping, and finally send it to Satu-Sahat. So we had to do some analysis before this. We had to design the data exchange workflows. We had some BPMN diagrams that explain how this workflow is going to go. So this diagram that you can see here, I don't know if you can see it clearly, but what we're saying is when a workflow is triggered, get codes from lookup tables. So these lookup tables is how we're going to store the data dictionaries that say, when you see a visit case or a case property in that visit case that says head examination, map it to this FHIR resource that has this low-ink and SNOMED codings. So we had to define those lookup tables or data dictionaries, and our workflow, what it would do was fetch those lookup tables and then create that mapping based on that lookup tables, and then create an encounter, create an immunization. But we also implemented some logic so that if this workflow was retried, we wouldn't be creating the same encounter or the same immunization again and again, right? So we want to make sure that if a part of this workflow fails and we retry it, we check that we haven't previously created this encounter. And if we had, then, okay, we're not going to create it. We're just going to proceed to the next step, which is creating immunization, right? And then we also do the same for immunization and just to make sure that we're safe whenever we do some retries. So this is the workflow that we designed. So we started by designing the workflow, and inside each of these steps, we would get like a case property, or inside each of these workflows, we'd get a case property from ComCare or a list of case properties from ComCare that looks similar to this, that have some properties on this side. And then what we would do was, depending on what we're receiving from ComCare, we would try to determine what FHIR resources would need to be created. So for example, for this snippet that you're seeing here, we would create like a patient to capture the patient demographics, an encounter to capture that visit, condition to capture that patient's diagnoses, and observations to get like those lab test results and stuff. So to do that, we had to create a mapping specifications. So it's like this Excel documentation where we have like this destination resource, so patients, encounters, observations, and then we'd have that source resource, and we would define which case properties from the source resource would map to that destination resource. And if there's any transformation that needs to be applied, we describe it there, and then we would take that mapping spec, which would govern the way that the workflows are going to be designed. And the developers using Open Function are going to write some code using that mapping spec that will transform this design into like a proper Open Function workflow. So just to show you what this mapping process looks like, so for each of these use cases, we'd have an Excel sheet that looks similar to this, and we would define the FHIR resources on the left. What kind of data type are they, or what kind of data type is being expected for this? So, for example, for vaccine code, we'd be expecting codable concept. And what's the source data for this specific one? So visit.vaccine administered. And then what kind of data transformation would be expecting for this case property from ComCare? That's what's defined here. And based on this definition, we can transform the source data into like a proper FHIR resource. So mapping specs are very important. We can also use them to map options or concepts, such as LOINC, SNOMED, and ICD-10. So we can specify which case properties would map to which of these terminologies. So after having these in place, the workflow design, the mapping spec, the final output of all of this would be an Open Function workflow configuration. So we have a canvas where we can design our workflows like this. So what we're saying here is every time you receive a request, so this webhook trigger, every time you receive a request, get codes from that lookup table, create an encounter, create an immunization, and then finally update that encounter status to finished. And so the diagrams that we designed earlier, the mapping specs that we defined dictate how this is configured and what the code inside each of these steps look like. So if we would expand this, each of these steps on the canvas, what we see would be like an editor where our code would reside, and also the input that we're receiving for each step. So each step is going to receive an input. So the first step is going to receive a post from ComCare maybe, and then using that input, we're going to create an encounter. And here you can see us creating an encounter using that mapping spec that we designed earlier. But this is like very little code that you have to write to create that mapping. And then you'd connect the different steps using these edges. So you can even define conditions for those edges. So if something fails, go this route, and if something is successful, go on this route. So some of the logic will live on the canvas itself, but some of the logic for each of the steps is going to live in this editor. So now that we have our workflow configured, I just want to go through some of those concepts that we talked about earlier, data dictionaries. And here you can see an example data dictionary that we defined. So here is a table for observations, and these are, I don't know if you can see them. Yeah, I think it's fine. These are a list of case properties that we're receiving from ComCare. So there is a case property that says abdomen that's captured during a doctor's consultation, and that is mapped as an observation on FHIR. And we're saying use this as category and use this as code when you create that observation. And the value type is going to be a value string. And finally, just get whatever text you're getting from this abdomen case property and use it as a value string. So for each of the case properties that we think it should be mapped as an observation, we add them here, create this mapping table, and this is going to be consumed in our Open Function workflow. So we could also do it using the Open Function editor, that our mapping logic could live there, but it's going to be very messy and very hard to maintain. But having it in an external service where you can easily, or like even a business analyst can easily modify it or add a case property to this list makes it very much maintainable. We do something similar for storing diagnosis information with their respective ICD-10 codes and medication informations with their respective KFA codes, which is what they use in Indonesia for medication terminologies. And yeah, I mentioned this earlier. For managing mapping rules, we can have it live directly in the open function workflow. We usually do this when we're designing a very simple workflow and it doesn't have a lot of mapping logic. But usually FHIR is complicated. It's not very clean to have the workflow code or the mapping logic live in the workflow code itself. So what we do sometimes is use an external service like OCL or the source application like we did earlier with the ComCare lookup tables, or target applications using concept mapping in the FHIR app, or even this feature that we have on Open Functions, which we call collections, where we can store data directly within the Open Function application. So depending on your use case, you might choose to have your mapping logic live in any of these places. It just depends on how often this mapping logic is going to change and who's going to need to change it. Yeah, depending on that, you can decide on which of these locations you want your mapping logic to live. Yeah, so like I mentioned, this is an example of having the mapping logic living in a ComCare, the source app itself. And then another example that we have is when we're syncing patient data from a CHT, we have the mapping logic living in OCL. So we get that patient from CHT, get that mapping logic from OCL, and then using this mapping data, we map that patient. And finally, we create a patient on FHIR. So depending on your use case, you can have that mapping logic live in different systems. Just to share some learnings that we had from this project and from other FHIR-related projects, you want to get started with your mapping early on because it's not the technical part that takes the longest. The mapping part is the hardest part, right? So you want to get a sample input and a sample output data and want to get started with your mapping as early as possible. And documentations are very important. So to get started with that, you would need your documentations for the input system and output system, and that's where you would start your mappings usually. We've also used some tools like open function adapters, AI, ChatGPT, and open function AI assistant to help us draft the mapping, but we've only used it during build time. We're not using AI during runtime. So just to help us draft those mappings, and then finally it would need like a medical expert or even a FHIR expert to validate those results. The other thing is we always need to plan for error, because no matter how hard we try, there's always going to be that really erroneous data that's going to come in and break our workflow. So we have to plan for error and make sure that we have a process in place for handling that error. So we usually focus on mappings, on the technology, but we don't usually spend a lot of time trying to figure out what could cause my workflow to fail. And that's a really important point that we need to address. We can also automate our error handlings. So on Open Function, we can design like a workflow that sends an email to admins with like a compiled list of erroneous data. That way that can be handled and we can streamline our process. The other thing is FHIR has a lot of diagnostic messages when we send the wrong type of data, but it doesn't always catch all the validation errors, right? So we need to have some unit tests, and we should also sometimes plan for manual testing to make sure that we're sending valid and correct values to our FHIR destinations. Yeah, I also mentioned having clear data dictionaries and how it's important to be flexible on modifying our source applications. Sometimes we might not be capturing the data that we want in the way that we want it. Sometimes we might not even be capturing the data that we need for the FHIR resources. So we should be flexible when and where possible to like modify our source application. We should also be alerted when the FHIR IG or the source application is somehow modified, because that would definitely break our workflows, right? So there needs to be proper documentations and communications in place to make sure that we are alerted and ready to maintain our workflows and pipelines if there's any changes made in the FHIR IG or the source applications that affect the data structures that's received or sent. I think that's it for me, but any questions?
And we've got time for one, because we're running a bit behind, but I shall be here the whole session. You had a question before. Does someone else have a question?
I have a question, but it also applies to the other speakers as well, which is, did you end up using the FHIR like safety checks, the clinical safety checks? I haven't heard them talk about one, and so we kind of wondered if other people are even using them or if they're even helpful.
Safety checks is in like validation measures that you get back from FHIR?
Yes.
Or
they've got an implementer's safety checklist, but I haven't heard of anyone using it yet.
yeah,
Do you know about that person?
no. But we have someone from Satsat that could speak.
Yeah, are you using that?
We're also not using that.
Okay.
Still a new concept, actually. Relatively new in terms of implementation and consideration of testing.
Okay.
And then maybe one more quick question while Richard's setting up.
Yeah, sure.
So my question was that if there is a central kilo or something like that, what happens when the central piece changes, and what will happen to the mapping tables at that point?
Yeah, so you're saying the requirements at the government level in this example change. This is where I actually was pointing to the process of like ongoing maintenance. So actually, do you want to speak a little to like, what's next with Osbury team and kind of helping manage this?
Yeah, so our plan with the Osbury team is we're going to give them training on how to maintain this workflow, a basic introduction on what this workflow looks like in workflow function, and what they can just maintain it if.
We're also like thinking about like version locking. They've got version. What's the stuff to step on. Yeah, and that's like a great example of at-scale implementation of IG. But they've got their whole kind of documentation layer on top of that, as well as collections of Postman for different use cases, tooling, stuff like that. So definitely worth checking out. And you will see how they do versioning and release notes and all that. Richard.
I think we've made it, but something was automatically controlling the scrolling, now paging from one page to another, so I don't know if we're going to stay well connected here, but let's see. Right, guys, just a very quick, we're running out of time, so I don't want to spend too much time on theory. I do have a practical example that I want to show you, transforming CHD patient to a FHIR patient, questionnaire response to an observation, vice versa, using Postman. So I just want to very quickly get to through some very basic theory part, and then I'm going to jump straight into the practical part. So first of all, what is FHIR mapping's language? It's a specification designed to facilitate the mapping of data between different data models, specifically in the context of the FHIR standard, and used by the FHIR structure map resource. So what that means is that when you create your FHIR structure map resource, which is automatically created by the FHIR IG publisher, the FHIR mapping's language is translated to the structure maps resource. It's actually written as a JSON kind of artifact. You can even create this using FHIR shorthand if you really wanted to, but the preference is, of course, to use FHIR mapping's language. It translates data from various sources. We learned about that already. I don't think I need to specify more time on that. And maps are unidirectional. So what that really means is if you want to transform data from source A to target A, you're going to have to do a transformation for that. If you want to get it back, you have to do a reverse translation for that. And the reason why FHIR doesn't do that for you automatically, because there might be some complexity, some additional data validations, which they don't know what you're going to do. It's impossible for them to say, I know what conditions, what validations you're going to put into place. For that reason, if you want to have bidirectional transformation, one structure map up and one structure map back down. Very important. And I mean, I think that's pretty much standard with, I think, any data transformation approach, right? I would probably imagine. It is a structured approach to specifying how to extract, transform, and load, when using FHIR native implementations, the data into a FHIR database. Standardized mappings will improve interoperability. So what that really means is, in the context of a FHIR implementations guide, if you implement structure maps to solve proprietary to proprietary, it could be proprietary to format to proprietary, whatever the case is, it kind of reduces the overhead and the complexities of implementers trying to adopt similar FHIR transformations in their use case, in their context. They can simply say, let me take this implementations guide and I can make mappings work. Then I just start trying to figure out how am I going to actually really do this. It's a single point of truth, which is a FHIR implementations guide. And it's flexible in the complex mappings and conditional logic is supported to handle various data formats and structures. That's quite important to know as well. It's relatively easy to understand, sort of, a syntax for developers and analysts alike to adopt when creating and maintaining mappings. I don't know how many of you in this room have actually physically created some artifacts using FHIR mappings language. While I might want to contradict my own statement, after a while, it can become relatively easy, but you can get really complex use cases, guys. You can have several structure maps trying to solve one problem. Like we saw in one of the presentations that Jose did. It could be a question and response going to a logical model, then from a logical model going to the FHIR resource. There's different points in time where you want to have these different types of transformations and validations taking place. What's also nice to know is that when you create your structure map resource using FHIR mappings language, there's also, I haven't personally implemented it yet. I know it does exist. But you can validate that when you get your data, as it tries to analyze, first of all, what do I need to transform this to? Let me check this against a resource, or let me check this against a specific profile. So before data gets transformed, and you say, yeah, give it back to a mediator to push this off to a server for persistence, let me make sure it's compliant, doesn't violate the base specification. You're not using a code, or you're using a wrong code where you should be using a specific code. You've got data missing when you should have data, and so on and so forth. We learned about implementation guides, sorry, I always make it a plural for some reason, a little bit earlier, where that is a specific use case implementation, right? So you can actually validate your data, your transformed data against a specific profile in the implementation guide. Right, guys, so just diving into some requirements. Well, implementing data transformation using FHIR structure maps. I like to kind of just call this requirements. So what you probably want to do is you must think about creating a logical model. So what that really means is, what are you trying to transform? What is your source structure? What are you in format? What are you transforming from? And in this kind of assumption, I'm saying that we want to transform to FHIR. It could be to HLSIN version 2, HLSIN version 3. It could be some data model to some whatever the heck the other data model is. It doesn't even have to be to FHIR. That's, I mean, you could actually do that if you wanted to. You can literally proprietary source A to proprietary source B. It doesn't even have to be FHIR. FHIR can actually support that, but I don't think you really want to implement FHIR specifically to have that kind of transformation, right? But you can actually do it. So what you need to think about is your data requirements. What is the format, that message that's going to be sent to the destination, at least to your interoperability layer, to your FHIR server where the data transformation needs to happen, into the HIE. What is that source data format, and what is the structure of that message? Now you need to define a logical model. If you don't define a logical model, the FHIR specification is going to say, well, I don't know what to do with this. I'm getting this message, but you're not a FHIR resource. I don't know what you are. I'm just not going to do anything, so I don't know what to do. Now, if you define a logical model, you're saying, this is what my structure is going to look like. So I've defined this in a FHIR implementation guide. I'll show you a little bit later what that looks like. Here's I just made something up. Okay, I said this is observation status. So I'm trying to capture code, a patient, encounter performer, breastfeeding status, and date. And then when you start looking at this from a format and structure point of view, this is the JSON snippet of what this actually looks like. Now, I didn't go and actually, specifically for the process of data transformation, I didn't go and make a whole completely different data structure that's against what I'm expecting to receive. Or should I say what I'm expecting to be sent into the HE, which I need to work with. I try to make this logical model set as it maps, at least it's a close representation, a very accurate representation of what that structure and format's going to look like as it gets sent into the HIE. Okay. Then what you need to think about is concept maps. So now while you have the structure map FHIR resource, you can also call concept maps. So what that really means is you can take some localized or proprietary terminology or vocabulary to define what this diagnosis is, what this observation is, what this medication is, whatever, right? And then you can actually map this to something more specific, like a LOINC or SNOMED. You can go from LOINC to SNOMED. You can go from SNOMED back to LOINC. Whatever the case is, you can define a forward and a reverse transformation of those codes, or at least the interpretation of those codes within a concept map resource. Now, with a structure map resource, you don't think necessarily will need to always just think about transformation of the structure and the format, but what about the code? You can call concept map resources from a structure map resource, very importantly. Then we move on to, okay, I don't expect you to understand all that there right now. I just want to kind of show you what a structure map looks like as it gets written using FHIR mappings language. I'm going to go into the implementation guide very shortly to show you what that looks like better. But here you can see I'm defining a source and a target. You can have multiple targets. You can have one source coming in of data that needs to be transformed. You can have multiple targets. I want this part of this data must go to a observation. This must go to medication records. This part of the data must go to, I don't know, a condition resource, for example. You can actually have multiple targets, what I'm trying to say. In other words, in simpler language, you can have data coming in, and you can separate this or fragment them into more specific individual FHIR resources from a single message coming in. Here you can see I'm calling the translate function. So what this means in this example, I'm simply saying, let me do my transformation, but I also want to call a concept map. I want to translate from one terminology to another. In this case, I have a proprietary, I think it's a Boolean, true or false, and I want to convert this into the LOINC equivalent. I think it's for breastfeeding status, actually. Yes, it's breastfeeding status. But let me just quickly, let me just quickly go into the implementations guide, quick. Implementation guide. I keep making it a plural for some reason. So I'm not going to go through this full implementation guide. It's just going to take forever. But this is something that we've, this is my playground RG. So if you want to use it, by all means, it's part of the presentation. There is a link to it as a resource. Feel free. I've got CQL. I'm busy with SQL on FHIR. There's a lot of structure maps near. There's some concept maps as an indication. Feel free, clone it, have fun. It's really entirely up to you. So what I want to specifically show you is this is what a concept map looks like when I find it. Yep, here we go. Right, so I think we might have seen this before. And this first one, I'm simply saying I want to translate from or convert from a Boolean true proprietary that I'm using locally in my exchange to a LOINC equivalent and vice versa. So it's a forward translation, and here's the reverse translation. And then what I want to show you is an example before we get into the demo. Not that one, sorry. Anyway, let me take something more simpler. Okay. In this particular example, I've called this one map CHT patient to a FHIR patient. I'm not going to go through all this code, guys. I know not everyone in this room is a developer, so it's going to just take too long to go through this code. But what I do want to show you is that I'm actually taking the message coming in, which in this case is the CHT payload, patient registration payload, and I want to convert it to a patient resource. How am I doing this? From the source, _ID. We saw from Tom's presentation earlier, I think it was Tom, that he had an _ID as a data element, right? Let's see, where is that specifically in FHIR, right? So let's put that just kind of into some sort of confirmation. Let's go to the logical model. Here's CHT patient. Here we go. Can you guys see? But yeah, _ID. There's my first data element from the payload coming in from CHT patient. Now what I'm saying is I must convert this to the patient resource, which is ID. Notice there's no underscore, because in the context of FHIR, there is no underscore in _ID. The ID element is something that's used within FHIR to logically create references from one resource to another. So in the context of FHIR, which is a part of every single resource in FHIR, you have an ID element, which is a logical reference between FHIR resources. So I'm not going to go through all this in detail. Like here, we can see we've got name. So we've got name coming from the CHT patient. Yeah, it's fair enough that the name element's the same in the patient FHIR resource. Here we can see we're capturing for phone. So this is where it's fine. So the CHT patient payload is capturing a phone number. Great. They're not capturing, like, say, system phone, like in the context of FHIR. They don't need to. That's irrelevant. That doesn't make sense. So what they're doing is absolutely fine. So they're capturing the phone number, but what we now can do as part of FHIR, we can say, we know this is a phone number, to kind of just add additional kind of quality to the mapping in terms of the FHIR artifact once it's done. We can say that don't just capture the value, which is the phone number coming from CHT patient. We can actually also say the system is phone. Why are we saying system phone? Let's have a quick look, and then I'll move on from there into the demo. Let's just quickly go to, where are we now? This is why it's also very important to actually navigate and understand the FHIR resources themselves by navigating the specification to really understand some of these things. Okay, we said, I'll make this bigger now. So telecom, we got contact point. We were talking about phone, right? Okay, so we're getting the value. What is system? We've got email, phone, fax, pager, whatever. Now, if I didn't actually capture the system, it's a phone number, sure, but you might not always, I don't know, maybe it's not captured properly. You're not really reassured that it's a phone number. But what we can actually, because we know it's a phone number in the context of this use case, we can say systems equal to phone. So that could actually lead me down another very detailed discussion about things overall. I don't want to get too technical with these discussions. So let me rather move on to the next part of the presentation, and then I want to dive into the demo. So from a testing point of view, this is where it's very important to ensure that once you've created your FHIR structure map, make sure that your syntax and what you've actually done can be compiled, and it can be, in other words, it can be understood by the server that's going to be interpreting this, and it actually gives you the desired results. Now, you're not going to get all of this in one single shot of testing. There's two different ways of testing this. The first thing is you can actually use the Matchbox Validate API. Here's a link for this. So what that really means is once you've created your FHIR structure map resource, you upload your structure map resource to this particular website, or at least to this API, which is designed by Matchbox, and you can specify your structure map resource. It's a JSON resource. Then your logical models. There might be more than one logical model for this, right? And you upload your logical models. Once you've done that, you will actually get a response back. You will tell you if there's any errors. I'm getting warnings from this because I didn't actually specify some of these, like, what is this for? It does not resolve. So this particular logical model won't resolve because I didn't upload any other. My IG is not publicly, it's not published. So what that means, I couldn't actually specify my IG as well as say, yes, Matchbox API, understand my package structure definition for this logical model. So that's why it's actually giving me a warning right now, because it doesn't know how to find this. That's what's giving me a warning. It's not saying it's wrong, it's just saying I can't find the logical model. Okay, the point is, if you go to this, this is where you'll add your structure map. I'm going to quickly download a structure map quickly from my IG. Give me a second. I'm just going to take, I don't know, what is this one? Okay, I'll just take this one again. So I'm using the logical model for CHT patient logical model. So I'm going to download the JSON artifact for this. I don't know what happened there. Oh, sorry, I'm clicking on raw JSON the whole time. Okay, so we've got the logical model. Let's quickly go to the Matchbox, add file. Now what I'm going to do is I'm going to go to the download. Here's my structure map. Okay, now what's actually telling me is that it's not actually finding, first of all, the logical model, because I didn't upload the logical model, right? So right now it's saying I can do partial validation of just the syntax of this FHIR structure map, but I can't really make any assertion if this is actually really correct. So what I'm going to do now, I'm going to download the logical model for this. The one that's missing is the CHT patient logical model. So let me just quickly go back to my IG. Guys, I know this is a lot to take in, but it's important. It's important to know because this is the full process. Logical models, CHT patient logical model. Okay, now let's download this JSON artifact. Here we go. Now I'm going to upload this. Now you can see over here, I've got, well, 2 errors. Now those errors will disappear once I try to validate this again after uploading the logical model, because now it's finding the logical model, but now it's going to give me warnings. What's going on here? Let's try this again. So I don't know why I can't see anything here. Supposed to allow, there might be a bug in this. Let's see. I think there's a bug here, guys. Yeah, there's definitely a bug in here at the moment. Because you can't read this in properly. I'm going to try one more time, but you get the gist of it. Then,
Richard, we're coming up on a half hour left.
Okay.
I know you've got a breakout on structure maps. We can like keep you on the screen to keep going, or is there something else you want to wrap up with?
I want to show, okay, well, we're basically on the live demonstration anyway. So unfortunately, guys, based on time, I'm only going to be able to do one demonstration. So what I'm going to do is I'm just going to bootstrap a few things. So there's a public server. It's called, well, the Matchbox testing server that I use for my structure map validation and execution to transform your data. This Postmate collection is part of the resources that's listed in this in the presentation. So please feel free. All these artifacts are there. If you want to use it, you can clone it, you can play around with it. Otherwise, it is accessible by every single one in this room. Okay, it is public. So what I'm going to do is I'm just going to quickly execute this structure definition. Then what I want to do is I want to go to a CHT patient. Now this particular part is where I'm going to create, first of all, the structure map. Right, and this particular structure map is for CHT patient to FHIR patient. Now I'm going to execute the structure map. I'm calling a very particular structure map, and it's called CHT patient to FHIR R4 patient. Remember I said you need one structure map per direction. So right now I'm transforming to FHIR. If you want to get it back from FHIR back to the kind of proprietary CHT patient, you have to do another structure map. So now if you have a look at the body, you can see I've got, here's a kind of a trimmed down version of CHT patient with just a few basic elements. Now I'm going to send this in. Okay, I think I forgot to process something. I think something has changed. Give me a second. Something has changed. Sorry, I just want to see something here. I think something has changed in this. We don't manage the server, guys. It's managed by the ADHIS team.
Do you want to just describe maybe what the goal is here?
Yeah, so basically, that's such a pity.
It is a pin.
Just try something. I'm going to try one more thing here. I'm going to try outside of ADHS.
We do believe you.
Yeah, it's
This
just
always happens with live demos, yeah.
no, very, very frustrating. Just bootstrapping a few things. For some reason, this one, I don't know what happened there. But anyways, now something's changed with ADHS and I just clearly forgot to update it. But let me just look at this other one. So here's an example of where I'm transforming questionnaire response to observation. So I've just bootstrapped a few things. I've executed my structure map just to kind of have that artifact ready for usage. Here you can see I've got an observation that's been specified as my input. Yeah, it specifies my input. And now I'm going to execute this. No, something has changed. I don't know what it is.
But you should see, right, a really nice observation output there. Is that right?
Yeah. Oh, no, there we go. Sorry, there we go. That's right. There we go. It's working now.
Yeah, so input, questionnaire response. Output.
Yeah, that's so strange. I don't know what's happening there. So here's a questionnaire response that I've sent into the server. Here's my questions. Only one question at the moment for is breastfeeding. I'm passing a proprietary code of false with this proprietary code system that I've created. I've executed the structure map. What the structure map resource structure map artifacts doing right now is taking that data based on the syntax that's been provided, and I'm converting this into an observation. And here is the loin code that's been translated from the concept map of true for breastfeeding status, and it's giving me the loin equivalent. Yeah, so I have no idea what's changed with the CHT patient. That's all on me. I've been making random things, changes on the fly. There's so many different presentations. I probably broke something. So sorry about that, guys. But you get the gist of transformation, right? Easy, eh? No.
Actually, you want to flip the slides? We'll take a question about flip the slides, and then Richard's going to do a breakout group. So for those of you who want to dig a little bit deeper into structure maps, Richard's going to take a group in the room to dig deeper. But yeah, question is we're pulling up slides.
I was just going to mention, are you familiar with the FHIR Path Lab from Brian Postel?
I've heard of it. I think I've actually seen it in one or two of his presentations. I haven't used it yet, though.
It's another tool to use kind of like that, but it's all graphical. You don't have to use Postman, and you can post in your like map file as along with the like input resource, and then it'll do the mapping for you, and it'll output the output resource along with like the trace of how it was done. But it's all in like a GUI. So again, it's not as efficient, but if you're practicing or trying to learn it, it's useful.
Maybe if you can, and thanks for bringing that up, maybe you can do a short demo for us just now, actually. So I don't have to put you on the spot. If you can, it's good awareness for everyone, actually.
Yeah,
So.
maybe with the structure map group. So guys, I'm sorry, we're running a little